Hello, good day. I am very happy to tell you that we are very near to an ending of our course, which is the subject matter, the hydraulics. So this is the last chapter, which is hydrodynamics, and it is my privilege to share to you out of my simple knowledge, no, and self-discovery, as well as from the knowledge I have absorbed from my teacher or instructor of fluid mechanics and hydraulics. So without further ado, so let's start hydrodynamics. So this is the last chapter, chapter 9. Hydrodynamics. So when we are talking about hydrodynamics, it is dealing with the study of motion of a fluid and the interaction of the fluid with its boundaries. The basic principles used in hydrodynamics are the Newton's laws of motion, which can be stated first. A body at rest will remain to be at rest, or in motion will remain in motion with a uniform velocity along straight line until acted upon by an external force. So that is law of inertia, no? So law of motion by Newton. So first, law of inertia. Second, a particle acted upon by unbalanced force system has an acceleration in line with and directly proportional to the resultant of the force system and inversely proportional to its mass. So it is law of force. And lastly, in every action, there is always an equal and opposite reaction. So that is law of stress. So remember these three laws, no, of motion by Newton, or Newton's law of motion, law of inertia, law of force, and law of stress. So first topic for chapter 9 would be force against fixed flat plates. So again and again, please be understanding with my penmanship, or bear with my penmanship, because I really hard positioning my hand for rest is assured that I will be uh, discussing to you the topic well. If I have been mistakenly forgotten or forgetting the terms or pronunciation, or mentioning the symbols, no, so I will try my best to correct them. So back to the topic. Consider the jet of fluid shown to strike a flat plate held normal to the path of jet before contact of mass of fluid. Mass moves with an initial velocity, and as it strikes the plate, its velocity in the x directions is v sub 2, which is less than v sub 1. This change in velocity is caused by the force exerted by the plate on the jet, as stated by Newton's first law of motion. Accordingly, if this is the jet, So as you can see, there are velocities, there are forces, there are mass acting on a global axis, which is y and x, no? So by Newton's second law of motion, wherein F prime is compressing or going to the body, which is against a force, no? Which is F prime equals to mass times acceleration, wherein m times, we know that the acceleration is v sub 2 minus v sub 1, or in simple discussion or explanation, the second velocity minus the second velocity all over the time. And we have known that mass over volume is the mass density, where in mass we can put it as mass density times the volume. So therefore our F prime is mass density or raw volume times velocity minus second velocity minus first velocity all over time. But don't forget, volume over time is discharge or flow. This is a force exerted by the plate to the fluid. From Newton's third law of motion, which is law of stress, no, the force exerted by the fluid to the plate is equal to the direction. So F is equal to F negative F prime, 'di ba? Kasi opposite sila. And can be expressed, no? Ganito. So F is negative nito, thinking that volume over time is discharge. So mass density times discharge times second velocity, subtraction between second and first velocity, no? And remember that negative nito, di ba, v sub 1 minus v sub 2, di ba, same lang, i-distribute natin yung sign. So negative v sub 1 plus v sub 2, so v sub 2 minus v sub 1, so same thought. So mahimo na siyang, or magiging rho times discharge times v sub 1 minus v sub 2 ating force. Or we can write it, no? Pwede din to at pwede din to. Discharge unit weight over acceleration due to gravity times v sub 1 minus v sub 2. So itong formula to, okay din to. If the plate is fixed, so take note that if the plate is fixed, so our velocity or second velocity would be 0. Then the above equation becomes F equals now to rho times discharge V, or simply discharge times unit weight over G times V. Ito. So if fixed plate, again, F is force, P is mass density, Q is quantity of fluid or discharge that is having cubic meter per second the unit, and velocity 1 and velocity 2, and initial and final velocity in meter per second, and yung gamma is unit weight of the fluid in meter per cubic meter or kilonewton per cubic meter. So let's have an example so that you can relate to the formula that I have introduced to you. So the first example, or the example, no? So the first example would be a hose and nozzle discharge a horizontal water jet against a nearby vertical plate. The flow rate of water is 0.03 cubic meter per second, and the diameter of the nozzle tip is 30 mm. Find the horizontal force necessary to hold the plate in place. So, first things first, let's draw it, no? For example, this is the hose, no hose, and nozzle. Ito. So it was aimed daw sa fixed never vertical plate, which is ito. Let's say, diba may force na against, may force na going, so F prime, no? Tapos ito, it says na 30 millimeter velocity, thinking na is a flow rate, I mean discharge in 0.03 cubic meter per second. So from the formula, F equals to F prime equals to so mass density times the discharge times the velocity, and we get first the velocity, which is Q over A, wherein given naman ang discharge 0.03 over using the orifice, no, this one is a jet, pi times 0.03 square over 4. So our velocity now is 42.44 meter per second. So therefore our F, or F prime, equals now to 1,000 kasi water and mass density, diba, times discharge 0.03 times velocity 42.44. So the answer is 1273.2 Newton. So this is the answer for first example. So second example, a jet of water flowing at the rate of 0.12 cubic meter per second hits a vertical building wall horizontally at close range with a force of 7,000 Newton or 7 kilonewton. Determine the diameter of the jet in millimeter. So let's say this is the building. So solution. Let's say this is the building, no? And paana may force going in, which is force natin is 7,000 Newton. So we are very interested, or we are only focused with diameter sa jet. So we are using F equals now to discharge unit weight V over G, no? From this formula. When again, if there is a fixed plate, so there is no velocity 2 or in final velocity. So take note that Q is equal to 0.12 cubic meter per second, and V is Q over area ng jet, diba? 0.12 over pi times D squared over 4. Or simply 0.12 times 4 over pi d squared. Right? So this is the value for V. So input natin dito, and there's a force given, diba? 7,000 equals now to 0.12, diba, discharge. Unit weight natin would be 9, 8, 10, right? Kasi naka-Newton naman to. So, we need Newton here. Kung 9.81, so kilonewton na. So, 7 pinidari if kilonewton na itong kanandari. Anyway, so Newton, dapat in terms of Newton din ang value, constant value ng unit weight. And over 9.81. This one is acceleration due to gravity na. And times natin dito, it turns out na 0.12 times 4 over pi d squared. So doing the math, cross multiplication, it turns out that our d squared now is 0.12 times 1,000, diba? Magiging 1,000 to. Times 0.12 times 4 over pi times 7,000. So square root both sides. So our D is, or diameter is 0.05118 meter of a meter. So times natin to sa 1,000 millimeter over 1 meter, cancel ang meter. So our final answer is 51.18 millimeter. So this is the answer. So that's it for first topic. Again, force against fixed plate or fixed flat plates. The second is force against fixed curved vanes. So very interesting topic, no? So force against fixed curved vanes. So ganito yan. So this is the section 1 and this is the section 2. So y, x, velocity 2. So deflection din dito. Velocity 1 here. And again, this is a jet. And always remember, there's a force now acting going to the body or the jet, and of course the component Fy and Fx. So this is phi, so this is called dynamic force on fixed curved vanes or vane. The x and y components of the total force exerted by the fluid against the fixed curve vane. Again, there is a fluid here acting. Can be expressed sa ganito na way. Fx mass density Q v sub 1 x minus v sub 2x, which is along x lang to ha, along x, and Fx equals to Q unit weight over G v sub 1x minus v sub 2x. So along y, fy equals to rho q times v sub 1y minus v sub 2y, or fy equals to q unit weight over g times v sub 1y minus v sub 2y, wherein f equals now to square root of fx squared plus square root of fy squared. I mean, square root of the two summation of the squared fx and y, fy. So wala na ni. And tan phi is fy over fx. Right? So example. So the example, a jet having a diameter of 15 mm and a velocity of 12 meter per second is deflected through an angle of 60 degrees by a fixed curved vane. Determine the horizontal and vertical components of the force exerted by the jet on the vane. Neglect fraction. So the solution is, so first things first, again and again, draw for illustration. So based from the problem, no, it is said na this is 15 mm diameter ang jet. Tapos may initial na velocity na 12 meter per second. And along y, along y yung force, along x yung force. And yung second velocity or final velocity, ito v sub 2x, dito v sub 2y, and this is the 60 degrees, which is ganyan ang center nito. So our v sub 1y equals to 0. So fx equals to mass density discharge times v sub 1x minus v sub 2x. Our v sub 1x equals to v1, which is 12 meter per second, and v sub 2x is 12 times cosine 60, which is 6 meter per second, and q equals to av, no? Therefore pi times 0.05 square over 4. This is the 50 mm times 12. So our q now is 0.0234 or 36 cubic meter per second. So our fx equals now to 1000 times 0.0236 times 12 minus 6, right? So our fx is 141.6 Newton, which is going to the right, or to the right. Again, we are asked note the horizontal and vertical components of the exerted or the force exerted by the jet on the vane. So now let's find the y. So Fy equals to mass density times discharge times v sub 1 y minus v sub 2 y. So v sub 1 y equals to 0. V sub 2 y is 12 sine 60. So you ask, bakit naging ganito? Of course, kapag malapit sa angle, no, v sub 2, so cosine. Kapag malayo, in the opposite side siya, so sine. Di ba v sub 2y is opposite ng angle, or in the other side. So let's use sinus, and it is 10.39 meter per second. So our Fy now is 1000 times 0.0236, and wala tayong v sub 1y, 0 minus ito v sub 2y, 10.39. So our F sub y is negative 245.204 Newton, or simply 245.204 Newton downward. So these are the answers. So the next topic is force against moving wings. So as you can see here, same with the earlier topic. So what is the difference is that there is this one, this curvy arrow, and it is called U. So later on you will know what is U. So this is section 1. Section 2, there's a velocity or initial velocity and the final velocity. But think of this. If there is U, or it is relative velocity, so there is also, we call V prime, as well as this one, U. So if we blow out this one, it turns out na ganito yung drawing. V sub 2, and this is V prime, and this is the U. So if you are familiar with the rectangular or parallelogram law, which is state na you duplicate this arrow to this and this arrow to this, so it is forming beta, no, angle. Again, this is U and this is V prime. So our goal is that we need to know, no, more about the angle and mga components. So this one, so V prime is not exactly as final velocity along X. So it is summation of the two, which is si V prime as well as si U. This is theta cosine theta, right? So V sub 2 X equals now to V prime plus U, again V prime, no? U cosine theta. So this one naman, di ba, forming a angle of perpendicularity or point of perpendicularity. So this is V sub 2y U sine theta, right? So therefore tangent beta is equal now to V2y over V2x. That's sorry. As well as V sub 2 equals now to square root of V2x squared plus V2y squared. So we have this, no? These are the importance. important formulas. So with this, this is relative velocity, and the topic is about moving vane. If this is the vane, so let's draw four vane. And there are no moving vane. If this is the first one, second jet, which is the first one is V sub 1. So meron tayong V prime, V prime, V prime, V prime. Second jet, the third one, and the last. So, mayroon tayong flow na siningan. Way ng relative velocity. And may V1 dito. No? Ang mga V1 niya. So, lastly, this one, it is the V2, which is meron ding U and B prime. The X and Y component of the force exerted by the jet are given. Fx equals to mass density Q prime V sub 1x minus V sub 2x, or Fx equals to Q gamma acceleration due to gravity V sub 1x minus V sub 2x, as well as our Fy is rho Q prime V sub 1y minus V sub 2y, or Fy is Q prime gamma over G times V sub 1y minus V sub 2y, or Q prime is area times relative velocity, diba? Supposed to be V, but we can write it as Q over V U, which is, this is the area of a jet, and therefore, or take note that U is V sub 1 minus V sub prime. Take note for this. Again, V sub 1, V prime is relative velocity. I mean velocity of the vane. Velocity of the vane, I mean. U is the relative velocity. Q prime is the quantity of water deflected by the vane. So, quantity of water deflected by the vane. V sub 1, of course, the initial velocity, no? Before it struck the vane. V sub 2 is the absolute velocity of jet as it leaves the vane. So, leaves the vane, enters the vane. So, example. So, the example is a jet having a diameter of 50 mm and a velocity of 15 meter is deflected by a vane which is curved through an angle of 60 degrees and which is moving with a velocity of 6 meter per second in the same direction as the jet. Determine the x and y components of the force exerted by the jet and its direction and velocity as it leaves the vane. So again and again, let's draw the illustration. So I am advising to use mga ruler no or guides. But if you are able to do some sketches so that you can show me or show to me the illustration, so it is okay. So v sub 1 is 15 meter per second. Take note that the jet is 15 millimeter diameter, and there is a force Fy, Fx. Again, v sub 1 y equals to 0, and the angle of deflection is 60. Again, this is a vane. So v sub 2, v sub prime, the relative velocity u, and take note that the v sub 2 y is 2x is 6 meter per second. No, I mean this is 6 meter is the v prime, which is again the velocity of the vane. So at this is stated, diba, which is moving with a velocity of 6 meter in the same direction as the jet. So v prime is 6 meter per second. Relative velocity is v sub 1 minus v prime, and it is 15 minus 6 is 9 meter per second. So Fx is rho cube prime v sub 1x minus v sub 2x cube prime is a u. Therefore, pi times 0.05 squared over 4 times 9. So cube prime is 0.018 cubic meter per second. So v1 x is v1, which is 15 meter per second. v2x is v prime plus u cosine theta, which is 6 plus 9 by u cosine 60, right? So v2x is 10.5 meter per second. So our fx is 1000 times 0.018 times 15 minus 10.5. So our fx is 81 Newton, which is going to the right, no? So Fy naman, mass density Q prime V sub 1y minus V sub 2y. So V sub 1y equals to 0. V sub 2y is U sine theta, or let's say 60 na agad. Sorry, 9 times sine 60, it is 7.29 or 79 meter per second. So our Fy now is 1000 times 0.018 times 0 minus 7.79. So Fy is negative 140.22 Newton, or our Fy is 140.22 Newton downward. So those are the two answers. And the other question is velocity and the direction. The v sub 2 is square root ng v sub 2x plus average ng v sub 2y squared. I mean, parang may ulo siya, no? So, 10.5 squared plus 7.79 squared. So, v sub 2 is 13.07 meter per second. And therefore, our beta now is v sub 2y, v sub 2x, or simply beta is 36.57. So these four are the answers. So second to the last topic, which is forces developed on closed conduits. The force exerted in a closed conduit of either constant or varying diameter is a resultant of the dynamic force and the total pressure exerted upon the end sections of the fluid contained in the conduit. So there is words varying diameter. So the topic na to, let's draw like this na. Broken lines. So varying yung diameter from bigger to smaller. So 1, 2, forces F1 no, equals to P sub 1 A sub 1, and this one is going inside. We're going to the vein, I mean closed conduit. F2, which is P sub 2 A sub 2, and there's also F sub 2x, F sub 2y. So there is resultant Rx as well as to Ry. So this is the resultant. This is phi. This is the angle of the block. This kind of process, no, it is reducing bed. So this is forces on pressure conduit. The dynamic force exerted by fluid on the bend is Fx equals to Q unit weight G times V sub 1x minus V sub 2x, or Fy is Q gamma G times V sub 1 Y minus V sub 2 Y. The X and Y components of the force reaction on the bend can be computed from the following formulas, which is summation of forces along X, Q gamma G times V sub 2 X minus V sub 1 X, wherein F sub 1 minus Rx, diba? F sub 1 minus Rx minus nitong F2, which is cosine na, diba? F2 cosine theta, F2x as 1, or same with F2 cosine theta, minus F2 cosine theta equals to Q gamma over G times V sub 2x minus V sub 1x, and summation, so this is very useful, no? Summation of forces along Y, wherein Q gamma G times V sub V sub 2 Y minus V sub 1 Y. So this is another formula. So I will be giving examples so that you can relate, no, or we can use the formula shown to you. So the example is a 45 degrees 300 millimeter by 200 millimeter reducing bend. So correct the word, no? Bend, hindi bend. So reducing bend yun. In a level pipeline carries water at the rate of 280 liter per second. Determine the components of the force necessary to hold the band in position. The pressure at the entrance is 345 kilopascal and the friction in the band is negligible. So let's draw the illustration. So first, the broken lines for our bases. So from big to small, from big to small. F1 equals to P1A1, F2 is P2A2. Velocity along X, velocity along Y. D1 equals to 200 millimeter. Pressure 1 is 345 kilopascal. Here is D2 is 200 millimeter and pressure 2 is unknown or to be known, no? And this is 45 degrees. This is R sub Y. This is R sub X. And this is R. So Q equals now to Q1, or the continuity equation now, Q2, which is 280 liter per second, or convert to cubic meter per second, it would be 0.28 or 280 cubic meter per second. So F1 equals now to P1 times A1, which is 345 times pi times 0.3 squared over 4. F1 is 24.39 kilonewton and F2 is P2A2, right? And we haven't known the or gotten the pressure or second pressure, so let's use the Bernoulli's energy equation, which is BEE and V sub 1 squared over 2G plus pressure 1 over gamma plus Z1 equals to V sub 2 squared over 2G plus P second pressure over gamma plus Z2. So we will be getting the velocities. First, first velocity or initial velocity no equals to Q over A1 and 0.28 over pi times 0.3 squared over 4. So it is 3.96 meter per second, and V2 is Q over A2, which is 0.28 over pi times 0.20 squared over 4, or it is 8.91 meter per second. So input the values that we have solved. 3.96 squared over 2 times 9.81 plus 345 over 9.81 plus 0, since the datum is along the z sub 1 lang, and 8.91 over 2 times 10.21 plus p sub 2 over gamma plus ang z2 is a 0 also, and we are interested with p2 only, right? So I find it very easy if we do not cross multiply ing or detaching the gamma no, later on na. So the answer or the solution now is 3.96 squared over may squared pa pala dito over 2 times 9.81 plus 345 over 9.81 minus 8.91 squared over 2 times 9.81. So P2 over gamma, which is 31.92 of a meter. So P2 now is 31.92 times 9.81. So our P2 is 313.14 kilopascal. So going back no sa it dito, we can input now the value. So F2 is P sub 2 divided by A2. So 313.14 times pi times 0.20 squared over 4. So F2 now is 9.84 kilonewton. So using the formula that we have arrived or formulated or derived, yung mga summation no along summation of forces along x and y axis. So diba F1 minus Rx minus F2 cosine theta equals now to Q gamma over G times V sub 2x minus V sub 1x. So V sub 1x is equals to V1, which is 3.96 meter per second as we have solved, and V2x is V2 cosine 45, which is our V2 is 8.91, and the answer for V2x is 6.3 meter per second. So now F1 is based on our solution 24.39 minus Rx, which is to be known, this is the unknown man, minus F2. F2 is 9.84 times cosine 45 equals to the discharge is 0.28 right here, no, times gamma, which is 9.81 over 9.21, cancel. So our V sub 2 is 6.3 minus 3.96. So now 24.39 minus Rx minus 6.96 equals to 0.655. So, ipagpalit natin itong dalawa. So, Rx is negative 6.96 plus 24.39 minus 0.655. So, our Rx is 16.78 kilonewton. Components ng reaction naman no ang ating ato ang pangitaon. Next, Ry, it is the base sa natin formula. Ry is F minus F2 sine theta equals to Q unit weight G times V2 Y minus V1Y. So Ry is minus to 9.84 sine 45 equals to 0.28 times 9.81 times V2Y is 8.91 sine 45, right? V2Y, ito. So there is no V sub 1Y, 0. So our Ry is 9.84 sine 45 plus 1.76. Ito lahat na 1.76. So our Ry is 8.72 kilonewton. So these are the answers. So now let's proceed to the last topic for hydraulics, and it is very interesting, no? Water hammer. So sounds heroic, but actually this phenomenon is, or maybe you have experienced and or noticed or observed. If you haven't, so this is the very best example. So once you turn off the faucet or the hose babe or whatever you call gripo, and once you turn off, diba, it experiences or shows you shaking. So that is water hammer, no, because of the shock or resulting shock or pressure rise in a pipeline caused by the sudden decrease or stoppage of motion. So once you stop the motion of the water, so the shock or the shaking phenomenon na imo na observe, that is water hammer. So this is more paano siya? For example, this one, if this is the dam or the reserve or tanke, and this is the faucet, no? Or the water line, and this is the faucet. There is a force, diba, going out gikan ani because this is the source of water. As well as once you stop or turn off the faucet, so there is force pod na ihatag, which is C from point A to B. So these are the two forces. So that's why there is shaking or shock na to ma-observe. And this is the length. So from here, so this is a normal energy grade line or AGL. Which is X, no? And that's this grade line is transit HGL. So this line is the rapid closure. And this extra is the instantaneous closure. So again, this line is the rapid closure, this line is instantaneous closure. And the height here is pH over gamma. So for rigid pipes, there are rigid pipes. There are formulas involved pala when we see a faucet shaking or undergoing water hammer. Is equals to square root of E sub B over rho. And for non-rigid, pipes, is equals to square root of AB over rho times 1 plus ABD over AT. The time for the pressure wave to travel from A to B, ang time A to B, or back again, is called, or T equals to 2L times C, or over C. For instantaneous closure, which is the TC, or the time closure in seconds, is 0. Instantaneous or pH plus of V CV, and the rapid closure, which is our time closure, is less than to the T, which is equals to 2L over C, with pH equals to VVC. Later on, you will know what is C, slow closure, which is TC, is greater than sa T, which is 2L over C, or pH now is 2L V rho over TC. So C here is celerity of pressure wave in meter per second. AB, if you have remembered in chapter 1, so it is bulk modulus or modulus of elasticity, which is in GPE, For water at 30 degrees Celsius, the bulk modulusity is 2.25 by 10 to the power of 6 Pascal. And there is big difference between E sub B and E. E is modulus of elasticity of the pipe wall in PA, Pascal. T is pipe thickness in mm. D is internal diameter of pipe in mm. T sub C is time of closure, and seconds now, and L is the length of the pipe in meter, and V is velocity of flow in meter per second. pH is pressure change due to water hammer in PA, and of course rho is density of fluid in kilogram per cubic meter. So I will be giving an example so that we can use the formula that I have shown to you. So this would be the last example that I am giving to hydraulics. So I've been working a lot doing the videos, and it comes to my attention that, or the feeling of, you know, all the hard works that I have put into to make I think for part up to part 24. Anyway, without further ado, so let's continue the topic about water hammer, because this is very interesting one. If the velocity of flow in a 600 millimeter diameter cast, again, phi is diameter, no, cast iron pipe, which is E, which is bulk of elasticity, 8.29 by 10 by 10 to the power of 9 Pascal, be changed in 0.25 second from 6 meter per second to 0 meter per second. By closing a valve 300 meters from a reservoir, what probable increase in pressure due to water hammer will be expected? Close the valve. The pipe wall is 20 millimeter thick, and the bulk of modulus or bulk of modulus of elasticity. The other one is bulk modulus of elasticity lang. So as you can see, no, there is like mga hint or direction like 300 meters. This would be the L. Anyway, cast iron pipe, it would be a non-rigid. And we are asked what probable increase in pressure. So pressure due to hammer will be expected. So it would be pH. So pressure change, no? So pH is rho CV, since it is for non-rigid pipe, which is cast iron pipe, the celerity equals to bulk of modulus elasticity over rho times 1 plus ABD over AT. So given naman ang bulk of elasticity, bulk of modulus elasticity 2.07 by 10 to the power of 9 over 1000, di ba, water man eh, and 1 plus 2.07 by 10 to the power of 9 times our D is, di ba, given man 0.60 na into meters man, all over our modulus of elasticity is 8.29 by 10 to the power of 9 times time, which is given naman 0.25 or no, it's not, this is not time. It should be times with the thickness, which is 0.02. No, it is not time ang T, it is the thickness. If or it is a pipe thickness. Okay, again, this is thickness. So if you do calculation or the math here, the answer would be 493.75 meter per second. So the time, so we already unlocked the Sino. So we are locking with the velocity. But we should first identify if it is rapid or instantaneous or slow. So the time of the pressure valve to travel around trip, if T to L over C, again, L is 300, C is, we have solved, 493.75. So the time is 1.22 seconds. So time check, check the time. The time of closure is 0.25, which is less than sa 122 na second. Diba? Which is, this is the T. So therefore, close is based sa atong or gihatag or condition, when time of closure is less than to T, it would be rapid. So close is rapid. So pH now is from this, no, 1000 times celerity 493.75 times V 6, no. So the answer is 2,962,500 Pascal, or according to Miga, so pH is 2.9625 megapascal. So this is the answer. So thank you for listening, and thank you for being understanding to my penmanship. Hoping that you have learned from my discussion, and good luck to your journey. Goodbye.